we have x squared y prime plus x times x plus 2, y equals e to the x. Now, is it in the form that we want? In this form, where we have the p of x? It is currently not, because we have the x squared in front of the y prime, the derivative. But we want the derivative by itself. So, we divide the x squared over, and we cancel the x in the numerator and then the 2 on the denominator. And we should get this. Now we have it in our form, because we can recognize that p of x is 1 plus 2 over x. And g of x is e to the x over x squared. Now we go ahead and multiply the u in order to get to the product rule. Again, we want to let u prime equals u times 1 plus 2 over x. We proceed. We write as a derivative. Divide the d over and multiply the dx over. Again, this is separable variables. Integrate. Upon integrating, we have the natural logs and then the constant. We take e to the power of on each side. We should get this. Simplifying, or using the exponent rule for sums, we have this. And e to the c can be a constant. And we use the log, the power property, I guess, to put the 2 over. And then the e and the natural log cancel, and we just have x squared by itself. Now, you may be wondering, well, this function cx squared e to the x does not look like the form that we derived in our technique. And this is where this example right here brings in light why memorizing formulas is not always trivial, because here it's not very noticeable. But if we jog back up a couple steps, we can see it is noticeable that p of x is indeed x plus 2 natural log of x. And if you work that out by taking the antiderivative of 1 plus 2 over x, which is lowercase p, you should get that. But again, that's not that very noticeable. It's very subtle. So just to keep an eye. So we go ahead and undo the product rule. We integrate. And upon integrating, we should get the uy by itself, but then we went ahead and divided the u. We substitute back in for u. We divide the constants, and we combine. We also divide x squared, and then we combine the c1 over c into a single constant, and then we see that there's 2 e to the x's that would become e to the 2x. So that's what we have. We go ahead and do our integral. Pretty simple integral. The 2 and the e to the x cancel, and then we have our solution.